Hello everyone, and welcome to the Pythagorean theorem intro. Woo! So our goal is to understand the Pythagorean theorem, which a lot of you guys have been exposed to, and associate with this equation, a squared plus b squared equals c squared. But this alone is not the Pythagorean theorem. There's a lot more to it than just memorizing an equation. And that's our goal for this week, is to truly understand where this comes from as well as how to use it. So first off, well, what exactly is the Pythagorean theorem? It is not just a formula. This is a representation of the theorem. The theorem itself is a very special relationship that's true of all right triangles. So let's start by learning about what is a right triangle and what makes them so special. So a right triangle, first off, is a triangle. This means it has three sides. The sides are all straight. It is closed, meaning it has no gaps. And those two things together make it what we call a polygon. So this gets us triangle. A right triangle is a triangle that has a right angle, meaning an angle that measures 90 degrees, like the corners of a square. The Pythagorean theorem only applies to right triangles. They have some special properties that result from having this 90-degree angle in them. If you do not have a right angle, you cannot use the Pythagorean theorem. If you're not a triangle, you cannot use the Pythagorean theorem. But if you have a right angle and you are a triangle, congratulations, the Pythagorean theorem comes into play. We call the two sides that are adjacent to the right angle the legs. And we call the side that is opposite to the right angle the hypotenuse. The hypotenuse is opposite of the right angle. It does not touch it. It doesn't matter how the triangle is oriented, these terms are always in relation to whatever the right angle is doing. So if you had a triangle that looked like this, hey, that's kind of crazy, but all that matters is where is the right angle? If the right angle is there, these two sides that touch it are the legs. This side that is opposite has to be the hypotenuse. So given this situation, the Pythagorean theorem says in a right triangle, the sum of the squares of the legs equals the square of the hypotenuse. This is the theorem. This is a representation of it. If a right triangle has side lengths A and B for its legs, and C for its hypotenuse, then we can say that a squared plus b squared equals c squared. So in a right triangle, the sum of the squares of the legs equals the square of the hypotenuse. Put another way, if I take leg 1 and I square it, meaning I multiply it by itself, and I add it to leg 2, and I square that, I should get whatever the length of the hypotenuse is squared. The sum of the squares of the legs equals the square of the hypotenuse. Or, as we often represent it as a formula, a squared plus b squared equals c squared, where a and b are the length of the legs and c is the length of the hypotenuse. By convention, we usually use a to represent whatever the shorter of the two legs is, but that's not required. Mathematically, it would work the same way, even if you choose to define your stuff differently. So let's see where this becomes really powerful. Let's say we have a right triangle that looks like this. 1, 2, 3, 4. This is a 3 by 4 right triangle. We want to know how long is the hypotenuse. Well, I know it's a right triangle, so I know the Pythagorean theorem is in play. A squared plus b squared equals c squared. I know the lengths of my two legs. 3 squared plus 4 squared equals this unknown hypotenuse squared. I know 3 squared is 9, because 3 times 3 is 9. I know 4 squared is 16, because 4 times 4 is 16. And I know that c squared is some number. This gets me that 25 is c squared. I need a number that times itself gets me to 25. So I'm going to take the square root of both sides. If I do that, I get that 5 is c. My hypotenuse has a length of 5. However, we can also solve other situations. What if we have a right triangle? This one is not to scale. And I tell you the hypotenuse is 13. And I tell you that one of the sides is 12. Well, it's still a right triangle. A squared plus b squared still equals c squared. That means that this unknown a squared plus 12 squared still has to equal 13 squared. A squared plus 144 has to equal 169. I'm going to try to get this a on its own, so I'm going to subtract 144 from both sides. That means a squared has to be 25. I'm looking for a number that times itself gets me to 25. So the square root of a squared should be the square root of 25. That means a equals 5. So if I know two sides of a right triangle, I can solve for the third one by using the Pythagorean theorem. But this is just the tip of the iceberg for the things that the Pythagorean theorem can do for us.